Hi class, it's Bill back with the second video on automated testing in Python. We got started and set up our files, and so we're going to continue now, and we're going to pick up right where we left off, which is, okay, we're going to write automated tests. How do we do that? So let me get back to our desktop setup, and then we will continue. Remember that here on the left we have our production code. I'm using that term to differentiate it from test code, which is going to be our automated tests. So I'm not sure that's an industry term, but that's my term just to make that distinction. So you got that. So let us now talk about how we're going to write our test code. First thing that we're going to need to do here is that we're going to need to import the stuff that we need so that we're able to have at our fingertips all of the functionality that we need. So let me bring this up a second. So the first thing that we need to do here is we need to bring in the code for the test framework, right? We need to sort of bring in that little library module. So we're going to import a thing called unit test, and that's going to have some definitions that we're going to need. We're also going to need to import our program. So in this case, it's called myprogram.py. With the import statement, you don't put the .py, of course, you just say import my program. That also assumes that these two programs are sitting right together, right? That mytest.py script is next to the myprogram.py script. So we're going to need to import both of those things to make sure we have available what we need. Right? So that's the first piece. Next piece is we're going to write some stuff that is not going to look that familiar to you because it requires some object-oriented programming code that you may not have covered. But don't worry, every time you use this, you're going to use this very same template, and even if you don't understand every line, you're not going to have to type this line because you're just going to copy it again, right? We're going to create a class, and that class can be called whatever you want to call it. I'm going to call it test my stuff. That's not a magic name, obviously, it's a silly name, but you can use whatever you want. The other thing is, in every one of these files, it can be the same thing. So you can just say test my stuff, right? Whatever you want to call it. Then you're going to put this word, and that is we're going to bring in from the unit test module, we're going to bring in a thing called test case. So what we're doing here is to create a class, and that class is going to contain all our test cases, and then later we're going to actually use that class. We're going to create an object from that class, and it's going to run our tests. None of that matters to you. All you need to know is that we're going to write our test cases here, right? So we're going to write all of that stuff right here. So we're going to come back to that in a minute and talk about the test cases. Now, after that class is finished, we're going to want to define our main, and the main here is going to help us actually create and run the test cases. So it's going to create what's called a test suite, which is a whole bunch of test cases that are related. It's going to create a test suite, and it's going to run that suite. So this is the code that you're going to use to do this. And again, you don't have to understand all of it. We're going to create a suite, and we're going to do it by calling unit test loader, right? That's going to load up a bunch of test cases, and you're going to call load tests from test cases. And then in parentheses, you're going to say, actually we can't continue here, right? Test my stuff. Right, now we could be smart and do this in Python and wrap the line, but you get the idea of what I'm trying to do here. Let's see, maybe, yeah, just to make sure you can see it. Yes, if you know how to wrap lines in Python, you could move that down to the next line, right? But that's the basic idea. You're going to load up the tests from the test cases, and you're going to provide the name of the thing that you did here, right? That's the name of the class. So you provide the name of the class, and it's going to load up all the test cases, and it's going to put them all in a thing called a suite. Then we're going to run that suite, and we're going to do that by saying text test runner. And then we want it to be a little more chatty than it normally is, so I'm going to set the verbosity level to 2, and then I'm going to ask it to run the suite. Again, this code may not make perfect sense to you, but that's what we're going to write, and then you're going to call main. So again, in sort of layman's terms, if you want to think of it, this creates the suite from test cases above, and this thing says run that test suite, being somewhat wordy. Right? There's not that many verbosity levels available here. Really, it's sort of not much, not basically nothing or information about each test case, and I'd rather see more information. So that's why I say the verbosity. So that's what we're really doing here is creating the test suite from those cases and then running it. Right? Now, if we run it right now, there's not going to be much much result, right? Because we have no test cases. So the next thing that we need to do is to write our test cases, right? So we'll come up here and we'll figure out how to do that. Now, one thing to note is when we create our test cases, they are going to be inside this class definition. So we're going to need to indent them in Python, right? So we're going to write one function for each test case. What is a test case? Well, a test case should focus on one particular thing or a couple of related things. Should not be a grab bag for testing a whole program or a whole bunch of pieces. So don't overdo your test cases. Test one thing, right? The general idea here is you might want to write one test method, one test function for every function that you have in your other program. If they're complicated, you might write more test cases, right? So let's create a simple test case called something like this. I want to test the function called square it. Again, the name here is not magic. You can call it anything you want. It doesn't have to have the word test. It doesn't have to underscore if you don't want to, but this is a simple way to name it, so that would be fine. The other thing is, this is a weird parameter. Doesn't make sense, but again, object-oriented stuff, so you just have to put it in there. Now, what you want to do here is to write a line of code that tests that the output from the function is what you expect in at least one scenario, maybe a variety of scenarios. And what we want to do, in a normal case, we might think of, well, we'll do an if statement and we'll do a print so that we can see the output. But no, what you want to do is to write that in a particular language that the test framework understands. And the typical word that you're going to see there is using the word assert. And just like in English, that means I am claiming something. I believe something. I assert that the following thing is true. And the particular method that we're going to use, we have to put the word self in front. Again, I'm sorry, object-oriented weirdness. The typical method that we're going to use is a method called assertEqual. Right? So it's saying, hey, I want to run from this object self, I want to run the assertEqual method that's part of the test framework. Then inside the parentheses, I need to put two things separated by a comma. And I'm going to say, I assert that the first thing is going to be equal to the second thing. Right? And one of these is going to be the expected result, and one of them is going to be the actual result, and we're going to compare the two. So in this case, I might put something like 25, and I'm going to call my program.assert, square it, and then 5, make sure my brackets match, and they do. So I believe that 25 will be the result of calling from my program, remember I've imported that, square it and passing it a 5. Now the order of these doesn't have to be expected and actual in PyUnit, but when you get to JUnit, that one expects the order because the way that it tells you the test results is more verbose, and if you make them backwards then it is confusing. So because that one uses it this way, I'll use it that way here. Expected first and then the call that yields the actual. Now, a lot is wrapped up in this because what it's going to happen is when you run these test cases, it's going to see whether those two things are equal. If so, that's a pass for this test case. If they are not equal, then it's a fail for this test case. But all that's taken care of for you. So really, assertEqual is the magic. It doesn't have to be the only line, right? Sometimes you have to do some setup stuff here. Sometimes you have other calculations, you create variables, you make loops, yes, you can do all of that stuff that you need to do. So these don't have to be one-line functions, right? You put whatever code you need to put here. All right, so let me now save that and let's run it and let's see what our output is. Ready? All right, so I have made a mistake somewhere. This is load from test case, sorry. So obviously we got to debug our own test code, sorry. All right, let's try again. Okay, so we ran that test, and now what we see is it says this test case, notice this is test square it, That worked okay. It ran just the one test, and the whole result of this test suite running is fine. Everything is good. That's what you want to see, okay at the bottom. If you see anything but okay, don't worry about the fact that this is red. Sorry about that. If you see anything other than okay, and you'll see more detail if there's a failure, right? But that's a good result, is that everything ran fine. Okay, so sorry about that. That was load test from test case. So just need to make sure we get that syntax right. Sorry about that. Okay, so the next thing that we want to do is, let's say if we let's go and make a mistake, because that seems awfully convenient that everything worked aside from the spelling here. So let's go make a mistake. Remember we said before, what happens if I accidentally press delete there? Sometimes the keyboard, you're not paying attention and something just gets deleted, right? Let's resave that. Now let's go run our tests again and see what happens. Ooh, look, we got. Now we say, look, in this thing, we're doing test square it, and in the process, we have an assertion error. You thought it was supposed to be 25. The result was 10. 25 ain't 10, right? And it shows at the bottom, failed. There was one failure. Aha. So we can run these test cases as much as we want, as often as we want, to verify that whatever we've done to the program didn't break it. The other thing to note is you can certainly go do other tests, right? For instance, I can do the same thing. I can say def test qubit, and again, we've got to pass self dot assert equal. It's not an S. It is in Java, unfortunately, but it's not an S here. We're going to say, let's say we went to 8, my program dot qubit 2. Right, save that, run it. Now you can see, oops, I've got to go fix my code up here. I got to fix my bug. Now come back and save it, and now run this again. And look here, everything's cool, okay, okay, and at the bottom, okay, everything's good. So you can write as many test cases as you want here, and that's great. Okay, so again, what you'll want to do is use this same framework. You can really use exactly all of the same code. All you're going to do is change the name of the program that you're importing, and then you're going to write test cases for each method, for each function that you have in your file. Right? Sometimes you need more, sometimes you need less, but that's the general idea. Test one thing. So let's look at a couple other small details that we'll want to pay attention to before we move on. Okay, so let's see, we've done this part. The slides here, you can pause them, but I'm just going to go through them because we've done all this stuff, right? The slides will give you a little more background. All right, so all of this stuff is, again, already in what we've discussed. I'm just going through the slides in case you want to pause them and take a quick look at what's there, but it's the same stuff that we just covered. Okay. Also, we talked about the fact that you can have more than one test case. There's some some examples there. Now, the other thing to note is there are some other goodies that are available to you besides just assert equal. Usually assert equals all you need, right? But there are some other methods that are very useful. For instance, assert not equal. I am verifying that A is not the same as B, whatever expressions are not equal to the same thing. There's also assert true and assert false. It saves you from having to say assert equal true comma A, right? I assert that true is the result if you evaluate A. Well, yeah, you can just say assert true and then provide the expression, or false. But this one's kind of cool, right? Almost equal. When you're comparing the results of floating point math, you often get comparison errors. So there's this thing called assert almost equal that says, look, I'm going to give you your two expressions, but then I'm going to say they're equal to a certain number of digits. As long as it's this many digits of accuracy that they're the same, I don't care if there's a little rounding error on the far side. So for instance, I can say assert almost equals, I think it's going to be 3.72, and as long as I compare it to 2 digits, that should be fine, right? In this case, you could certainly go all 4, but I'm just giving you an example. You can say, hey, these are about the same. So if you're comparing the results of floating point math, it's a good idea to use almost equal and make sure you go out to a certain number of digits, right? So that's a very convenient thing. So when we go back a slide, you can actually see almost equal used here, right, and almost equal used here. Okay, the other thing is there's one more wrap-up slide here that we might as well cover. Remember that test code is still code, right? You can still have bugs, so you still have to sort of work out the kinks in your test code. Be a little suspicious if everything goes perfectly the first time, right? Sometimes I like to introduce a specific error just so I feel confident that it would have caught it, right? Sometimes you write bad logic and that will pass any time, and that's not a good feeling. If you have a failure in a test, it could be a failure in the test code or it could be a failure in the production code. So you've got to go figure out which thing was wrong at that point. Also remember that if your production code evolves and changes, your test code has to be updated as well. Very often you're just adding on to production code, so sometimes you just need to add new tests, but if you make changes to your production code, you may have to go back and update the tests. Maybe not fun to do, but they've got to stay in sync with each other. Also, remember that it's very easy to make the same logic error in your test code and your production code. It's best if your test code can verify what the results are supposed to be from some independent source. Maybe the spec tells you that. Maybe you can find some other, oracle that will tell you what the results should be in a particular case. Because if you introduce the same logic, the same bad logic in both files, you're not really going to have that figured out, right? Found by the test code. Also, if you write your test code first, that's sometimes a kind of a good idea, because if you write your test code first, you'll think a little differently. You'll think more critically about your code, and then when you write your code, you will already have that in mind. So there is kind of a neat mindset that can be developed if you write your test code first. That's called test-driven development, right? That's a thing, right? It's a thing out in the world, test-driven development. So if you want to do that, you certainly can, and there's a way to write what's called stubs, which means you write sort of a skeleton of your program, but you really don't return real results. You write your test code, and then you keep writing your production code until it passes all the tests, right? That's a neat thing. Can't take it up any more than that here. The other thing to note is it may seem tedious, right? When you're writing these things, it's time consuming and it's tedious, but that's okay. There are some big rewards as well. When you submit your code, you'd like to feel confident, right? You'd like to know that your code is in good shape, whether it's at work or at school. The last thing you want to do is break something in the project, right? At Microsoft, we had a special little troll or a special little ugly something that sat in the doorway of the last person who broke the build, right? So if you turn in code that breaks stuff, sometimes there's a punishment. You have to go do some task that nobody else wants to do until the next person breaks the build, right? So you don't want to turn in bad code. You want to turn in code that's actually working. Right? So you want to feel confident, and when you have this whole suite of tests at your fingertips, you can just run it anytime you want. Right before you turn in your code, run it one more time, right? So those harmless, quote, harmless changes, which we know can break things, are not going to be a problem. So it feels very powerful to have a whole bunch of tests that you can hit one button, run all those tests before you turn in your stuff. So it is a really good idea to understand something about this. Again, in this course, maybe not a major part. In future courses, depending on your instructor, may still not be a big deal. But I really recommend you get into this mode. It'll make you think differently about your code. It's a good thing for you to know when you get out in the world. So there you go. That brings us to the end of this particular talk. I hope that these videos on automated testing on Python have been helpful, and thanks for watching them. Leave comments if you have some, and we'll see you in another video another time. Thanks.